Hello everyone, for this tutorial video I'd like to show how to dissect a cylinder into segments, which is actually somewhat more complicated than a segment of a circle or ellipse, because there are two distinctly different methods of figuring out a segment, as the segment of a cylinder refers to two entirely different things, which is not true for the segment of a circle. In particular, the first method of the segment of a cylinder can be simply the segment of a circle with height, exactly like how it worked with the sector of a cylinder. And so therefore, the volume would be volume formula for a segment of circle times height, and the surface area would be a rectangle which constitutes the diameter and height of the segment plus the area of the curve, which would be circumference times height, like for the normal cylinder, but times the percentage that would constitute the segment. However, what is tricky about segments of cylinders is that there is a second equally valid definition that does not fit the circle times height trick. In particular, if you slice the cylinder at one of its heights, you would get a segment of it that way, and you may hear the more formal term for a sliced cylinder is truncated cylinder, which means cut short. An interesting thing to notice when you truncate a cylinder is that if the two lines that truncate it are perfectly parallel to one another, then the resulting shape will still be a cylinder, just with a lesser height. But if one of the lines is tilted relative to the other, then we will get a more interesting shape that cannot be described with simple cylinders. In particular, we can see that the face of the cylinder, even though it is not made out of a countable number of shapes, can be seen as, with some creative thinking, a fully rotated trapezoid, just like a cylinder can be seen as a fully rotated rectangle. We can use this line of reasoning to prove the volume, because just like the length of the rectangle constitutes the radius of the cylinder, it should come as no surprise the length of the trapezoid would constitute the radius of the truncated cylinder. Therefore, we can see, since we can fit two truncated cylinders into one full cylinder, the volume of a truncated cylinder with a trapezoidal height would be 1/2 times pi r squared times height 1 plus height 2. As we remember, that was what we found for the height of a trapezoid. Owing to the complexity of the rotated shape for a truncated cylinder versus normal cylinder, it should not be too surprising that the surface area would be more complex. Although, since we showed the volume is 1/2 pi r squared times height 1 plus height 2, we can use the same exact proof to show that the surface area of the height of the truncated cylinder is 1/2 times 2 pi r times height 1 plus height 2. And since this makes up the majority of the surface area for the entire shape, we can simply add the area of the two circles, as even when one is slanted, they both are still circles, as they both still have constant radiuses. Now that I've explained how to figure out the segment of a cylinder, both using the traditional trick and using a more complicated method, I can explain how to figure out the sector of a cone next, which has a similar thought process to the sector of a cylinder, and in fact would follow basically the same formula, i.e. the volume of the overall cone times degree out of 360. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.